All right, y'all, we are gonna try this now. So for our first lesson, I used Show Me. I'm realizing now that I can just screen record and keep our lesson on Notability, which is what we've been using in class. So I'll be looking for some feedback to see which one you guys liked more. Both of them, I'm just writing and you can hear my voice, but I feel like Notability has a little more flexibility. So we'll see. So 2.4, winning the bonus prize, using strategies to find theoretical probabilities. So you remember our last class together, we played Gee Whiz, Everyone Wins, right? Where you all had to guess what color block you might choose from the bag. So following that same context, here we go. All of the winners from Gee Whiz, Everyone Wins game show have the opportunity to compete for a bonus prize. Each winner chooses one block from each of 2 bags. Each bag contains 1 red, 1 yellow, and 1 blue block. This bonus game consists of 2 events, right? Choosing from one bag and then choosing from the next bag, which can be called a compound event because we're not just flipping one coin or you're not just choosing one color. There are 2 pieces to this event. So the contestant must predict which color she or he will choose from each of the 2 bags. If the prediction is correct, the contestant wins a $10,000 bonus prize. Wow. What color choice gives you the best chance of winning? Well, I noticed that there are 1 of each color in each bag. So is any one color more likely than another? No, it is not. So I skipped problem A because it had you doing the experiment. And I don't know that all of you have the things you might need to do that at home. So unfortunately, we're just going to skip that part. But if you want to do this, it might be a fun thing to do with your families or your siblings, but that's totally up to you. So we're going to dive into problem B. Find all of the possible color pairs that can be chosen. Are these outcomes equally likely? Explain your reasoning. Well, for the sake of it being neat, I went ahead and just copied the actual picture of the tree diagram that would help you find this answer, right? So here's our starting point before we've done anything. In the first bag, you can either choose red, yellow, or blue. Then regardless of which one you chose for the first bag, for that second bag, again, it could be red, yellow, or blue. Red, yellow, or blue, red, yellow, or blue. Doesn't matter what you picked the first time. The second time, you've got those same 3 options. So our outcomes here, right, are red, 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 yellow, red, blue, yellow, red, yellow, 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 blue, blue, red, blue, yellow, blue, blue. All right. Are these equally likely? What do you guys think? All pairs are equally likely because there's exactly 1 of each color block in each of the bag. So, and the order matters in this game. So red, yellow is different than yellow, red. So each one of these outcomes is equally likely, okay? B2 says find the theoretical probability of choosing each pair of colors. Well, I see a total of 9 possible outcomes, and it says find the theoretical probability of choosing each pair. So each one is a 1 out of 9 chance. How do theoretical probabilities compare with your experimental probabilities? And because I didn't have you guys do problem A where you went ahead and did the experiment, we are just not going to worry about that one. Okay. So C says that Braylon and Akimi changed the rules of the game. Each contestant must predict which color combination will result from choosing a block from each bag. Braylon and Akimi make the following predictions. Akimi says, I predict 2 reds. So, or actually, I guess I already had that one circled. We will use red for Akimi, and so she predicts 2 reds. Boom, this is her prediction, right? Braylon says, I predict 1 blue and 1 red in either order. So that could be, sorry, it was red and blue. Yep, that could be red, blue, or that could be blue, red. Who has a better chance of winning? Well, Akimi has 1 possible outcome, whereas Braylon has 2 possible outcomes, right? So Akimi has a 1/9 likelihood of winning, whereas Braylon has a 2/9 likelihood of winning. And because 2/9 is greater than 1/9, Braylon is more likely to win. Does a contestant have a chance to win the bonus prize? Well, if we remember, to win, it just says the contestant must predict which color she or he will choose from each of the 2 bags. And we already said here that there is a 1/9 probability of that happening, right? You could say, this bag is going to be yellow and this bag is going to be red. That is 1/9 chance. It would be the same chance for any combination. So is there a chance to win? Yes, a 1/9 chance. Is it likely that a contestant will win the bonus prize? Well, it is not, right? There are 8/9 of a chance that you're going to choose the wrong color combination. And if you play this game 18 times, how many times would you expect to win? Well, you have to figure out what is 1/9 of 18. So 1/9 of, when we hear of, we're almost always multiplying. 18. 18 becomes 18 over 1. 18/9. 18 divided by 9 is 2. So if you played this game 18 times, you could expect to win 2 times. Does that mean you will absolutely win 2 times? It does not. You could not win at all. You could win 5 times, right? It's hard to say, but the theoretical probability is that you would win twice. Alrighty. If you guys have any questions about Investigation 2.4, go ahead and you can either email me or we can chat on Google Hangouts. Alrighty.